What if I told you there's a place in the universe where time stops, light disappears, and the laws of physics break down? Welcome to the mind-bending world of black holes, a cosmic mystery that defies everything we know. Black holes. Just the name conjures images of dark, bottomless voids in space, swallowing everything in their path. But what exactly are they, and how do they come into existence? Today, we're diving into the captivating science behind one of the universe's most enigmatic phenomena. A black hole starts its life as a massive star, at least 10 to 20 times larger than our sun. Like all stars, it burns fuel, mostly hydrogen, through nuclear fusion, producing a balancing act between the force of gravity pulling in and the outward push of energy from fusion. But what happens when the star runs out of fuel? Gravity takes over, and without the energy from fusion to push back, the star begins to collapse under its own weight. This is the dramatic beginning of a black hole, explaining the formation. As the star collapses, it shrinks to a point called the singularity, where the gravitational pull becomes so intense that not even light can escape. This creates the defining feature of a black hole, the event horizon. Imagine the event horizon as a point of no return. Cross it, and there's no way back. But don't be fooled. A black hole isn't just a cosmic vacuum cleaner, indiscriminately sucking up everything nearby. You could orbit one, like any other star, without being drawn in, as long as you keep a safe distance. Types of black holes. Now, not all black holes are the same. There are three main types: stellar, supermassive, and intermediate. Most black holes are stellar, formed from the death of stars. But the true giants of the cosmos are the supermassive black holes, found at the centers of galaxies, including our own Milky Way. The mass of these cosmic behemoths can be millions to billions of times that of our sun. But how did they form? Did they start small and grow over billions of years by gobbling up stars and gas? Or were they born this big, right after the Big Bang? Scientists are still on the hunt for answers. The strange physics inside a black hole. So, what would happen if you fell into a black hole? As you approach the event horizon, time itself begins to stretch. To an outside observer, it would look like you're frozen in time at the edge. But from your perspective, you'd continue falling, experiencing something called spaghettification, where gravity stretches you into a long, thin strand. This bizarre process is the result of an extreme difference in gravitational pull between your head and feet. But don't worry, you wouldn't survive long enough to become intergalactic pasta. Black holes and the universe's mysteries. Black holes aren't just terrifying, they're also a key to understanding the universe itself. Einstein's theory of general relativity predicted black holes, but the quantum world, which deals with particles and the very small, doesn't quite agree with what happens inside them. And this is where the mystery deepens. Some theories suggest that black holes might lead to other parts of the universe, like a wormhole or a passage to another dimension. But for now, these ideas remain in the realm of science fiction. Real-life black hole discoveries. In 2019, we got our first glimpse of a black hole, thanks to the Event Horizon Telescope. This shadowy image of a supermassive black hole, 55 million light-years away, confirmed what many had only imagined. But even more exciting are the recent gravitational wave detections, revealing the collisions and mergers of black holes across the universe. These discoveries give us a window into some of the most violent and energetic events in the cosmos, offering clues to how galaxies evolve and how gravity shapes the universe on a grand scale. Black hole, weather accretion, disks, and jets. While black holes themselves are invisible, they can create some of the most spectacular phenomena in the universe. When gas and dust get too close, they don't just fall straight in, they form a swirling disk called an accretion disk, heating up to millions of degrees as it spirals inward. This disk can become so hot that it glows brightly, outshining entire galaxies. And sometimes the black hole shoots out jets of energy from its poles, traveling at nearly the speed of light, like cosmic lighthouses beaming across the universe. These jets can stretch across thousands of light years, influencing star formation in nearby galaxies and shaping the cosmos on a grand scale. It's like a black hole is sending a powerful message to the universe, saying, "I'm here." Could black holes be wormholes? Now, let's get into a mind-bending possibility. What if black holes are actually wormholes, shortcuts through space-time? While it sounds like science fiction, some theories suggest that if a black hole has a counterpart, like a white hole, it could create a tunnel through space and time. The idea of a white hole, which is the opposite of a black hole, is fascinating. It's a region where, instead of everything being pulled in, matter is expelled outward. But so far, white holes remain purely theoretical, with no observational evidence. If wormholes do exist, could they allow for faster-than-light travel or even time travel? For now, these ideas remain on the drawing board of theoretical physicists, but they offer a tantalizing glimpse into how much we still have to learn about the fabric of reality. The paradox of information loss. One of the greatest mysteries surrounding black holes is the information paradox. According to quantum mechanics, information about physical states like the particles that fall into a black hole should never be truly lost. But when something crosses the event horizon, it seems like that information vanishes forever. So, where does it go? Stephen Hawking proposed that black holes aren't entirely black. They emit what we now call Hawking radiation, tiny particles that slowly leak energy from the black hole, causing it to evaporate over time. But here's the catch. If a black hole can evaporate, what happens to the information it swallowed? Does it come out with the radiation, or is it lost forever? This paradox challenges our understanding of both quantum mechanics and general relativity, two fundamental theories that explain the universe. Resolving it could reveal a deeper theory, something scientists call quantum gravity. Could black holes hold the key to a new era of physics? Conclusion. Black holes may be mysterious, but they're far from a dead end in our understanding of the cosmos. In fact, they challenge us to ask bigger questions. What really happens inside a black hole? Could they hold the secret to a deeper understanding of the universe, or even a path to other worlds? Thanks for joining us on this cosmic journey. If you loved exploring the mysteries of black holes, don't forget to like, subscribe, and share your thoughts in the comments. Let's keep the conversation going. What do you think lies beyond the edge of a black hole?